Following question reads that silver chloride is a white solid which is insoluble in water. Silver chloride is AgCl. It's Ag plus 1 and Cl minus 1 ions, and they are this ionic compound is insoluble. Which statement describes how a sample of pure silver chloride can be made? Now I'm going to talk about the preparation of AgCl in detail. AgCl is insoluble, and there's only one way where insoluble salts could be produced, and that method is called Ionic precipitation. Now, ionic precipitation is, since you're trying to make this AgCl, what you're going to do is you're going to find two soluble compounds and you're going to mix them. So, first thing is you need to find two soluble compounds, and one should contain Ag plus 1 ions and the other one should contain Cl minus 1 ions, and you're going to mix them. So one soluble silver compound that could be that you could have is, there could be multiple options that are soluble compounds that contain silver ions. So AgNO3 is one example. All nitrate compounds are soluble. So if I take AgNO3, I know that this is a soluble compound and it would be present in aqueous state. Similarly, I need a compound that contains Cl minus 1 ion, and that should also be soluble. So one soluble Cl compound that comes to mind is NaCl. That's very common, and that is soluble. Group 1 salts are all soluble, but there could be lots of group 1 compounds that can have Cl ions. There could be KCl, or you can have acids as well. They contain Cl ions as well, so you can have HCl. So there could be a number of compounds that contain Cl ions and that are soluble. So you're going to pick one soluble compound that contains silver ions and one soluble compound containing Cl ions, and you're going to mix the two compounds together. So if I mix these two soluble compounds together, soluble compounds, remember, dissociate when they are mixed in water. So if you mix silver nitrate in solution, the silver ions and the nitrate ions, they're going to dissociate, and you would have all these silver ions and all these nitrate ions just roaming around in the solution. They would be mixed in water. Similarly, let's pick NaCl. If I take NaCl and if I mix it's going to dissociate as well, like this silver nitrate. And sodium ions and Cl ions would be roaming in the solution. So you're going to have lots of sodium ions, lots of Cl ions, and sodium ions randomly just roaming around mixed in the solution. So you have all these ions mixed together. So that's your solution now. And these ions are going to randomly combine with each other. So they would start bumping into each other and they would start combining with each other. Remember, a compound is formed when a positive ion combines with a negative ion. So they're going to randomly combine with each other. But what's going to happen is that if silver ions and let's say this Cl ion, if these two ions, they get together, and over here there's another silver ion and a Cl ion, if they get together, AgCl, remember, we've already talked about AgCl is insoluble. That was the first thing that we mentioned, and that was that AgCl is insoluble. So what's going to happen is you're going to start seeing precipitates of AgCl forming at the bottom of the solution. This AgCl solid would be formed. AgCl solid would also be formed over here, and these ions, they would no longer be present in the solution. They would instead form a precipitate because they are insoluble, and you would start seeing their precipitates settle at the bottom. Here, as you can see, all the AgCl ions, they've now formed this AgCl solid, and they have settled at the bottom, and they would form a solid. And your solution would be left with sodium ions and nitrate ions. These two can also combine with each other, but the problem is NaNO3 that would be formed is going to be soluble, so they're going to remain part of the solution. They would dissolve back into the solution. They're going to dissociate back again. So two things would be formed. And here's my equation as well. Silver nitrate aqueous mixes with NaCl aqueous, it ends up forming AgCl solid, which settles at the bottom, and sodium nitrate would be formed, which would remain part of the solution. And what you're going to do is you're going to eventually filter this AgCl solid precipitate, and you can easily remove it. So this is what ionic precipitation is. Now let's go back to our question, and let's read the question again. Which statement describes how a pure sample of silver chloride can be made? So the first one is exactly the example that we did. Silver nitrate, mix it with sodium chloride, and you can get a precipitate of AgCl, which is going to be solid, and you're going to filter it out. So this option number A, looks perfectly correct. But also let's explore the other options. The second option is add aqueous silver nitrate to HCl, evaporate, and then crystalline. Now again, silver nitrate is going to contain silver ions, nitrate ions, HCl contains H plus 1 and Cl minus 1 ions. All 4 ions are going to mix together. A precipitate of Ag and Cl would be formed, and you just need to filter it. You don't need to evaporate it and crystallize because a solid is going to be produced. So it's an insoluble solid. You can't crystallize an insoluble solid. It's already in the form of a crystal. So the B option is incorrect. Option number C is also incorrect because reacting a carbonate with hydrochloric acid is going to produce a reaction. Salt, water and CO2 would be produced, but the salt is going to be AgCl. It's insoluble. It's insoluble, so you can't evaporate and crystallize. And this reaction would not occur because silver carbonate is a solid. So if you have AgCO3 solid and if it reacts with HCl, the salt that would be produced is going to be AgCl. Now that AgCl is quickly going to form a layer on top of the silver carbonate, and it would stop. I mean, there would be water produced as well, there would be carbon dioxide produced as well in the reaction when carbonate reacts with acid. But since the salt is insoluble, that insoluble salt is going to form a layer on top of the silver carbonate, and it would prevent the reaction from happening further. So it's not a very good way of making AgCl. But the reason why C is incorrect is because you're not going to evaporate and crystallize because AgCl is already a solid. You just need to filter it out. And the last one is you need to add silver to hydrochloric acid, filter, and then wash the residue. The problem with this reaction is metals react with acids, but the problem with silver is that it's very, very unreactive. It's very extremely unreactive. So the reaction is probably going to take a very, very long time, or it would require extreme conditions. You probably can't do it with dilute hydrochloric acid. So this is not a very good way of making AgCl because hardly any reaction would happen because of the low reactivity of silver. So option D is also incorrect. So option A is again your correct option.